Welcome to This Explainer. Today, we are embarking on a mind-bending exploration of natural engineering that's going to completely change the way you look at the world around you. We're talking about mechanics, materials, and physics that are so incredibly advanced, modern human technology is actually still struggling to catch up. If you appreciate efficient, focused learning and just structural brilliance, you are going to absolutely love what we uncover today. We're going to look closely at some of nature's most extreme designs to grasp highly complex mechanics that scientists are really only just beginning to truly understand.
Section 1. A flawless strike. Okay, let's dive right into this.
Our first subject is a creature from the ocean that completely redefines physical force, the mantis shrimp. Imagine, for a second, firing a gun underwater. The water resistance creates immense drag, right? It slows everything way down. Yet, the mantis shrimp accelerates its club-like appendage faster than a .22 caliber bullet leaving a barrel. It moves with such visceral, blistering speed that it literally boils the water around it, creating these localized cavities of vapor that collapse with flashes of light and intense shock waves.
And it's not just about the speed, it is about devastating impact. Behind a single punch from this tiny crustacean is 90 kilograms of sheer force. Just think about that. With this weapon, the mantis shrimp can smash straight through solid oyster shells, cracking open its heavily armored prey with absolute terrifying ease. And here's the crazy part. It delivers this catastrophic force not just once, but repeatedly over its entire lifetime.
Now this presents a fascinating central mystery. Look, if you or I strike something with extreme force, our bones can easily fracture. Even if human engineers built a machine to strike with 90 kilograms of force at bullet-like speeds, the synthetic materials would rapidly fatigue and eventually just shatter from all the stress. Yet there is zero damage to the mantis shrimp's biological fist, no wear and tear. So how on earth can living tissue and mineral withstand catastrophic, repeated impacts without completely disintegrating?
Section 2. The scientific secret of the fist.
You see, this isn't just fun ocean trivia. It's a profound structural secret that baffled materials experts and mechanical engineers for years. They knew the shrimp possessed a biological hammer of unprecedented durability, but they had to figure out how it actually functioned. Well, the breakthrough came from a team at the University of California, Riverside. Published in Science magazine, Dr. David Casillas and his team finally cracked the code, validating the immense complexity of this biological weapon. He said, "We solved the structural secret of this fist that does not break down even though it strikes thousands of times." To understand what they found, we really need to zoom in and look at the microscopic architecture.
The absolute genius of this design relies on three distinct, perfectly integrated working layers. First up is the impact surface. This is made of a highly dense, bone-like mineral designed to take the brunt of the initial shock. But the real magic happens beneath that. Step 2 is the inner core, where chitin fibers are arranged in a helicoidal, basically a spiral staircase pattern with the tiny spaces packed full of minerals. Finally, step 3 is the outer wrap. Parallel chitin fibers literally wrap around the fist, compressing the edges incredibly tightly. When the shrimp strikes, these layers work together to absorb the energy, forcing it to dissipate outward, and most importantly, this structure stops microscopic cracks from spreading. It acts as an incredibly advanced, self-containing shock absorber.
So why does all this matter? Well, this discovery isn't staying confined to marine biology. The aerospace industry is actively studying the precise structural layout of the mantis shrimp we just explored. Engineers are currently trying to mimic this exact three-layered biological architecture to build stronger, lighter, and vastly safer aircraft frames. They are literally analyzing the biology of a shrimp to figure out how to build better, more resilient airplanes?
Section 3. Living gears in nature. Let's pivot from the ocean to the land and see how this builds our understanding.
Meet our next incredible subject, the Issus bug. If the mantis shrimp is a masterclass in advanced materials, this tiny insect is a masterclass in raw mechanical synchronization. It can launch itself into the air at an astonishing 3.9 meters per second. That is a tremendous burst of acceleration for a creature so small, but generating that kind of instant explosive speed creates a massive physics problem. How does the bug ensure both of its back legs fire at the exact same millisecond to launch it straight forward?
The answer is, frankly, staggering. Scientists discovered actual biological gear wheels inside the bug. This was a shocking revelation made by Professor Malcolm Burrows and Dr. Gregory Sutton over at Cambridge University. They found perfectly interlocking cogs located right in the hind legs of the insect. Guys, this isn't a metaphor or a loose comparison. These are functioning, individually toothed gears inside a living creature. It actually marks the first time a genuine mechanical gear system was ever documented in nature.
And they are absolutely essential for its survival. As Professor Burrows explains, if there were even a very small timing difference between the two legs, it would yaw from left to right while jumping. You see, neurosignals traveling from the bug's tiny brain take just a fraction of a millisecond too long to perfectly synchronize those legs. So the mechanical gears physically lock the legs together. When one leg moves, the teeth catch, and the other is forced to move at the exact same instant, providing a perfectly straight, powerful trajectory. Without these gears, the bug would just spin helplessly out of control.
Section 4. The Inspiration of Engineering.
This brings us to a really fascinating intersection between human ingenuity and natural design. We have long prided ourselves on our mechanical and structural innovations, and this brilliantly illustrates a humbling reality. We look at the gear as a hallmark of human invention, the absolute foundation of clocks, engines, and the Industrial Revolution itself. It's a relatively recent crowning triumph in human history. Yet the exact same mechanical solution has been utilized perfectly by the Issus bug for millions of years. They definitely beat us to it. It's a wonderfully humbling reality check for modern science.
So what is the ultimate takeaway here for modern human engineering? Our brightest minds spend years and pour billions of dollars into high-tech labs, constantly searching for the strongest materials and seeking the most efficient mechanisms to solve our rigid physical constraints. But time and time again, we discover that the answers already exist. They're perfectly optimized, fully functional, and right out there in nature. We just have to look closely enough at the biology around us to find them.
Section 5. Signs of Creation.
Observing mechanics and materials this advanced naturally guides us from scientific evidence to a deeper philosophical reflection. When engineers finally discover the ultimate solutions to their hardest problems, hidden beautifully inside tiny insects and ocean crustaceans, it leads many to ask a pivotal question. Who, or what, placed these answers in nature? When we see natural engineering that completely surpasses human capability, it invites a pause. It asks us to look past the biology and the physics and to ponder the very origins of these flawless designs.
This profound reflection is actually echoed in ancient texts. Consider this verse from the Quran in the chapter Al-Ghashiyah, which asks, "Do they not look at the camels, how they are created?" It serves as a striking summary of our journey today. True, deep observation of nature, whether you're looking at the adaptability of a camel, the composite armor of a mantis shrimp, or the mechanical gears of a tiny bug, often forces us to ask deep questions about creation. It's a long-standing invitation to study the physical world as a potential gateway to understanding higher truths. Which leaves us with this final thought for you to take away today. Look, think, understand how they are created. For many, looking closely at the impossible mechanics of the natural world reveals the signature of a creator. Whether it's viewed through the lens of theology or pure evolutionary wonder, the ultimate answers to our greatest engineering challenges are literally walking, jumping, and swimming right in front of us. The only question is, are we paying enough attention to see them?